Hello everyone. So today we will discuss factor theorem. This theorem is related to remainder theorem. This theorem says if px is a polynomial of degree n greater than or equals to 1, that means we'll take a polynomial px of degree n and the value of n is 1 also and greater than 1 also. That means again this polynomial cannot be a constant polynomial. Other than that we can take any polynomial, same as our remainder theorem, and a be any real number. Then x minus a is a factor of px if p of a is 0. Now factor, this factor word you have already done it before. Yes, in our previous video we have done this question. So yes, this question number 3. Check whether 7 plus 3x is a factor of this polynomial. So here this is your px having degree 3 and this is your x plus a. Okay, and what we have to prove? We have to prove that this is we have to check whether this is a factor or not. Then what we did, we will check after putting remainder theorem. If after putting p of a, we just check that whether the answer is 0 or not equals to 0. If our answer becomes 0, that means this is the factor of that number. And if our answer is not equal to 0, that means this number is not the factor. So this factor theorem is same. This factor theorem says that we can say that x minus a is a factor of px when p of a is 0. Yes, as here p of a is not equals to 0 na, so we can say that this is not the factor of that number. Similarly here also, that x minus a is the factor of px only if p of a is 0. And you are already familiar that how can we find this value of a? How can we find this value of a? By putting x minus a is 0, then we find the value x equals to a, then we put the value here and then we find that whether it becomes 0 or not. And converse part is also true. What converse part says? That means if we have already given that p of a is 0, then definitely bache x minus a is a factor of. Now converse part is also true. What is converse part? That means that p of a is 0 if x minus a is a factor of p of x. Ji haan. In the first part, what we will prove? We have given that p of a is 0. Then we can say that x minus a is a factor. Okay. And in the second part, if we have given that x minus a is a factor, then we can say that definitely p of a should be 0. Okay. Now you will get more clarity while doing an example. So let's take an example. Check whether x plus 2 is a factor of this polynomial. Now we have to check whether this is a factor or not. And how can we say that this number is a factor or not? When we can say that x minus 2 is a factor of px if p of a is 0. Yes, that means if p of a becomes 0, then we can say that this is a factor. Okay, so now we will do. First what we will do, we will find a na. And how can we find a? By putting x plus 2 is equals to 0. Now find the value of x. X becomes minus 2. Okay, now this is the value of x. Now put the value in this polynomial. P of a is equals to minus 2 ka cube plus 3 into minus 2 ka square plus 5 into minus 2 plus 6. Minus 2 ka cube, 2 to the 4, 4 to the 8 and 3 is here, therefore we put the minus sign, plus 3 minus 2 into minus 2 plus 4. 5 2s are 10, minus 10 plus 6. Now again, minus 8 plus 4 3s are 12, minus 10 plus 6. Now, minus 8 plus 12. 4 minus 10 plus 6. Plus 4 minus 10. That means minus 6 plus 6, which is equals to 0. P of A becomes 0. That means by factor theorem, we can say that by factor theorem, if P of A is 0, then x minus A is a factor of Px. Therefore, x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. बच्चे, factor theorem has two parts. First part is, if P of A is 0, then we can say that x minus A is a factor of Px. And other part is converse of first part. That means, if x minus A is a factor of Px, then we can say that P of A is 0. Now, in the first example, which part we have used? Which part? Here we have to check whether this is a factor or not. Now we have not given that this is a factor. We have to check. So, that means we will use first part. Here we have to check that x minus A is a factor if P of A is 0. Okay. Now, in this example, what we did, we proved first that P of A is 0. Then we can use factor theorem that if P of A is 0, that means yes, x minus A is a factor of Px. Now I am taking another example. Find the value of k if x minus A is a factor of this polynomial. Now you have already given that x minus A is a factor. Okay, that means which part we will use? Second part, because here you have given that if x minus A is a factor, then P of A is 0. Okay. So here x minus A is a factor. That means then if x minus A is a factor of this polynomial, then P of A is equals to 0. So we can apply this formula using factor theorem. What we will do? So by factor theorem, P of A should be 0. Okay. Now first find A. So x minus A is equals to 0. Therefore x becomes 1. Now put the value of x. P of 1 is equals to 4 into 1 ka cube plus 3 into 1 ka square minus 4 into 1 plus k. Now we know that P of A is 0. And what is P of A? P of 1. Therefore P of 1 is 0. 1 ka cube means 1 and 4 into 1, 4. Plus 1 ka square, 1. So 1 into 3, 3. Minus 4 plus k. Now plus 4 minus 4 cancel out. 3 plus k is equals to 0. We have to find k. Now this is plus 3. Take 3 to the other side. 0 minus 3 is equals to k. That means k is equals to minus 3. This is your value of k.